Okay, our first task here is going to be to construct a graph that has the property that the y value doubles whenever x changes by this much. This much being this arrow being this long. So when x changes by this much, and of course the arrow points this way, so that means x changes by this much in this direction, y is going to have to double. So let's see how this might work out. Let's just start with a point. Okay, now we can put a point anywhere. I'm going to put a point right here. Okay, so now the x coordinate of this point, of course, is here, and the y coordinate is here. Now, see if you can sketch this such that when x changes by this much, and you should draw your arrow, draw your graph, when x changes by this much, y is going to double. And what point would we get? What's the next point that we would get? Okay, well, if x changes by this much, we start here. And we change x by this much. So now here's our new value of x. And y has to double. Well, here's the value of y. If we double it, we get about here. So x changes by this much. There's our new x. Here's our new y. And we simply do this. Now you should construct more points. 3 or 4 more points. Okay? Now, hopefully you've done that. Hopefully you've paused and done that. But I'm going to go to the new x now. Going to change by the same amount. So here's my next value of x. So let's call this the first new x, and this is the first new y. And I'm not going to label this one. This would be our second new x if we want, and whatever our y is would be our second new y. But now we change by this much. Here's our new value of x, and y changes. Well, y is this big, and y's got to double, so y is going to have to get up to here. So our next y value, of course, it goes all the way up here past the end of the axis as we drew it, but it's going to be up here, and our x value's here, so we can come over here to about this point, maybe not a very straight line, but we're going to be up around here somewhere. So that's going to be a new point. Let's put a little x on each point so we can distinguish them from anything else on the graph. So that was way up there in my writing, but that's okay. Now, if we want to do another new x, what are we going to do? Okay? Well, if you're doing this on a piece of paper you have in front of you, you might have room to put another one up there. Eventually, you're going to run out of room. Matter of fact, you're probably going to do that sooner or later. Well, I'm out of room. I'm not tall enough to do the next one. I don't have a board up there, and the camera doesn't go up that high. So what am I going to do? Well, I'm going to go this way. Okay? So this would be the x before the start. Okay, that's fine. We're perfectly okay doing that because this gives us a value of x. And the value of y, what should be the value of y for this value of x? How are we going to construct it? Okay, well, it should be clear that you construct that value of y by cutting this one in half. Since the value of y has to double between here and here, if you go from here back to here, it's going to have to cut in half. So we cut it in half, and we get this point. And then, well, now we've got a procedure. Okay, we can come over here and cut the y value in half. And you should already do this. And you should continue this on for ways. Okay, we get this. Now, the graphs that we've done where we're doubling x every time, it's x that gets doubled, not y, and y is tripling or quadrupling or whatever it does, those graphs couldn't get past the y-axis because every time we cut x in half, we're still to the right of the y-axis. So we keep cutting x in half and nothing happens. We don't get past the y-axis. We don't get past x equals 0. Now I'm going to cut x. I'm going to let x decrease again, and that's going to cut y in half again. And we can do that actually a couple more times. Okay, we cut it in half again. That's going to put us about here. And we can go one more. Move x over this way and cut the value in half. And now we're down pretty close to the axis, and it's going to get impossible to really draw it. Now, I can sketch a nice smooth curve that goes through all of these points. And the curve could continue on here, but it's going to get down so close to the x-axis that you're not going to be able to really tell it from the x-axis. In other words, you're going to have an asymptote with the negative x-axis. You're never going to reach it because you're just going half as great, half as great, half as great. You're never going to get down to 0. You've always got something, even if you can't draw it. Okay, now this kind of a function has a name. This is an exponential function. And this is a property of an exponential function. One way to express the property is that the y value doubles whenever x changes by some fixed amount.